Welcome back to Algebra 2, Chapter 11, Section 1 in this book. And we're going to be talking about sequences and series. And in a lot of ways, this is starting to get you ready, definitely for pre-calculus, but also calculus. So you'll learn more about that later. So what is a sequence and what's a series? Well, we're going to talk about a sequence first. So you have some numbers that have a relationship. 3, 6, 9, 12. What comes next? I'm thinking of a song. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Let's sing once more. 3, 6, 9. Oh yeah. Okay, maybe I'll stop. Okay, so obviously we're counting by threes here. So these things are called the terms in the series, and they're ordered. This is the first one, the second one, the third one, the fourth one. They can be finite, where they end, or they can continue forever, and then it's called infinite. Now, what is the rule? Like, I was able to guess what the next one was going to be. 3, 6, 9, 12. What's next? 15, right? How did we get that? Well, we're skip counting by threes. But you can't write the rule as skip count by threes. Instead, you have to think of a rule that is connected to the order. So what did we do to 1 to get 3? What did we do to 2 to get 6? What did we do to 3 to get 9? What did we do to 4 to get 12? And with each of them, we multiplied it by 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. So this is, you can always think of this as a number, but you can sort of think of it like the y, or a rule. A rule of what you do to a number is you multiply the number by 3. And so you can't just, the easy part is thinking of what's coming next. The hard part is thinking of a rule that relates back to the order. Okay, let's try another one. Now this one is easier. It's easier to see the pattern than to make the rule. And it's easy to go from the rule to the pattern. So all you have to do is say, okay, we're going to start with 1. 1 times 2 is 2 plus 3 is 5. Now we're going to do 2. 2 times 2 is 4 plus 3 is 7. Now we're going to do 3. 3 times 2 is 6 plus 3 is 9. And we can see it. 5, 7, 9 is going to be 11, 13, isn't it? Okay, let's try this one. Sometimes instead of doing this a sub n, they'll just do f of x, f of n, something like that. So first we say 1. So negative 2 to the power of 1 minus 1 is 0. Anything raised to the 0 power is 1. Okay, so now 2 minus 1 is 1. Anything raised to the 1 power is itself. And then we go on, 3 minus 1 is 2. Negative 2 squared is 4. Now we'll do our next one. 4. 4 minus 1 is 3. Negative 2 to the third power is negative 8. Now look at the pattern. It's going, each one of these is going on this pattern like of squared, but it's really 2 squared. And also notice that it's doing positive, positive, negative, negative. So a lot of times you see the pattern in the positive and negatives too. So this is a typical problem. They said figure out the rule, figure out the next thing. Well, it's easier to figure out the next thing. It's going 3 squared is 9, 3 to the third power is 27, 3 to the fourth power is 81. So we know this is going to be 3 to the fifth power, and it's going negative, positive, negative, positive. So this one is going to be negative 1 over 3 to the fifth power, which is 243. Okay? But how did we do it? What's the rule? What can we do to 1 to get that, 2 to get that, 3 to get that, 4 to get that, 5 to get that? You have to go from the order through the order to get here. So what you're actually doing is you're doing negative 1/3 to this power. So negative 1/3 to the first power is negative 1/3. To the second power, negative 1 squared is positive 1, and 3 squared is 9. Then we're back to negative again because it's to the third power. positive to the fourth, negative to the fifth. It's kind of hard to see my negative there. Let's put it up there. I like them in the numerator. Alright, so it's harder to go from the pattern to the rule. So it's kind of fun though, because it's a puzzle and you gotta work through it. So let's see about this one. See if you can guess it. We're going 2, 6, 12, 20. Is it a certain number we add? No. What do we do to 1 to get 2? Well, 2 times 1 is 2. What do we do to get 2 to get 6? Well, 2 times 3 is 6. 3 times 4 is 12. 4 times 5 is 20. 5 times 6 is going to be 30. So that's how you do it, but how do you write that rule? It's like this. Then you take the number and you multiply it times the number plus 1. So 1 plus 1 is 2 times 1 is 1. 2 plus 1 is 3 times 2 is 6. 3 plus 1 is 4 times 3 is 12. So that's the rule. And here they're writing it with f of x. Now, don't go, this all started with cannonballs. There's always a problem about stacking cannonballs because it used to be whoever did the best job stacking the cannonballs were more likely to win the fight back in the Pirates of the Caribbean time. So very important thing, a lot of math going into how to stack cannonballs. But of course, they don't always like your problem to be stacking cannonballs. So in your book, it's stacking oranges. What is the best way to stack oranges? All right. Now, the other thing is series. If you take a sequence and you add them all up, 3 plus 6 plus 9 plus 12, or negative third plus 1/9 plus negative 1/27, whatever it is, if you add them up, it's called a series. So here's our first one over there added up. It can be finite or infinite. Same thing. If it's infinite, it has an infinity on top. If it's finite, it tells you which number to start with and which term to quit with. So this one is that one that we were doing, 3 times n. And this crazy thing right here is called summation notation. That's fun to say. And it's a Greek letter. And what you do is on the bottom of the Greek letter, you write which term you're starting with, which number you're starting with. It's 1 usually, but not always. See, 1, 1. That's starting with 1. And then how many terms you're going to do and what the rule is. So this would mean that we're going to do 3 times 1 is 3, plus 3 times 2 is 6, plus 3 times 3 is 9, plus 3 times 4 is 12, plus 3 times 5 is 15. You add them all up. Now, our calculator will do it for us. So on your calculator, do alpha window 2, and it says something like sum note or something like that. You press it, and it will pop up this symbol with little blanks here. Now, your book likes using I's for the X's. I just like using X because that button's right there and I just push it and boom, it's done. So I did X equals 1 and then going through 5, the rule is 3 times X. You can also do N, you can do whatever letter you want, but I like X's because I'm lazy. Okay, and then you hit enter and boom, there's the answer, 45. Here's another problem in your book, and we were supposed to start with 1, go to 6, the rule is 2 times X. And the answer is 42. This one's fancy looking. You start with 3 on this one, go to 6. Just type it in exactly. 2 plus x squared, 94. And originally I put it in wrong because usually you start these with 1. So I did it with 1. I got like 103 and I thought, oh no, I did it wrong. I went back and looked. Have to do the right problem to get the right answer. Math is great. Come back and we'll do more of this. I think this is super fun. It's fancy. We look smart. And our calculator does it for us, so it's easy. Math is great.